Hi everybody, welcome back. So yesterday was pretty intense. So today I'm going to try to go a little bit less intense. So there's only 2 slides, 3 if you count this one. So today is day 2, welcome back. And we're going to be using concurrency for all the things. And the goal is to do live coding. I'm going to be live coding of a chat roulette server, text only, so it's good. Yeah, and thank you, Android. And then we're going to go into Q&A. So that's it. Let's start. So, okay, I'm going to disconnect my phone. Too complicated. So we're going to start by using some code. There's a bunch of things in here. I'm going to use Visual Studio Code. It's the editor that I use most of the time, but you can use whatever you want. And there's examples and images and then some things that I'm going to be using later. And there's also a back, just in case I mess it up and I have a backup of what I should be writing. So let's start with the main.go. And let's do our hello world. Ooh, I start. OK. Println. Hello. CERN. My shift key doesn't work really well because there's an Apple keyboard. So yeah. OK, so go around main.go. Hello, CERN. Cool. What else can you do? Go build. And that generates a chat thing because we are in the chat directory. So when you build a package, you get the name of the folder. So what is chat? It's a file that you can send around to any Mac, and that Mac computer will be able to run this. There's no need for any interpreters or extra libraries or anything like that. What if you want to send it to someone that uses Linux? Go as Linux, go build. And that's it. Now you have a Linux executable, and you can send that to a Linux machine or a Docker container or whatever. What if you have some weird friend that uses Windows? Same thing. Go as equals Windows, go build, and now you have chat.exe that I will not be able to execute here, but you can send it to any Windows machine, and they'll be able to run this whole program. This will work for everything that we're going to be doing today. It's going to be a chat server, but it will be able to run on any kind of platform. So let's remove the binaries. OK, so what I'm going to start now is I'm going to do a hello net. So I'm going to create a TCP server. So the TCP server is actually pretty straightforward. You're going to start doing net listen. And when you do net listen, that's going to be, oh, by the way, every single time I save, you're going to see that those import packages are going to be changing automatically. That's a tool called Go imports. And you should be using it if you're writing Go. It makes writing Go much better. So just install it and you'll just trust me. OK, so what are the parameters for this? First, the network. So what kind of network? That's going to be TCP. And then the address, let's do localhost 4000. That returns a listener and an error. Now in Go, you're going to write if error is not nil basically once every 30 seconds. And we're going to do log fatal error here. Log fatal will just help the program and print a message. You should be doing this only in the main function. If you do this inside of a library, it's pretty cruel to your users because you're taking down their whole server. So don't do that. OK, so what else can we do with this? So we have a listener, and we're going to write an infinite for loop. This is a while for loop. This is an infinite while loop. In Go, there's no while loops. There's only 4, which they're 2 letters shorter, so they're better. And if you don't write anything, this is basically the same thing as for true. You can write a Boolean condition. If you don't write anything, that's implicit. So this is an infinite loop. So we're going to do l.accept. OK, when you do l.accept, you're going to accept a new connection. OK, so you're going to get a connection and an error. If the error is not nil, log fatal error. Normally, if you're a good developer and you have time to do it, you should do something like couldn't accept connection, and then something like %v for the value. So that would create an error message that has a little bit more information about where it happened. Otherwise, it would just print it without any context. This is not compiling. Why? Because in Go, if you declare a variable, if you declare a local variable and you never use it, that doesn't compile. And that's good, because it actually catches a bunch of bugs. In Go, sometimes you will see things like in a for loop, you're creating a copy. You think you're not. you modify it, and it will tell you, no, actually, what you wrote doesn't do anything. This code does not compile. So it's actually pretty useful, although annoying, too, I admit. OK, so then we have a connection. And what I want to do is just print hello into the connection. So actually, you can do fprintln. So actually, let me remove a couple of things so you can do it bigger. So fprintln, it receives writer, an IO writer, which is that interface we talked about yesterday, the one with the write method, and a list of empty interfaces. That is a variadic argument. You can pass as many as you need of empty interfaces, which is anything. So you can pass any number of any things. So what is the writer here? Well, it turns out that the connection here, which is of type net.con, it's a connection. And if we go there, so let's go to the connection definition. OK, so I'm going to be doing here, go.net.con. So net.con is a really big interface. It is really big. But one of the things it does is read, write, close, and a bunch of other things. So it does have write method. So we can use it as a writer. So we can do write into the connection, hello, CERN. OK, so now I'm going to be running this, go run in the go. And from here, I'm going to use netcat. So now when I do this, it just says, hello, CERN. And it waits. Why is this waiting? Well, this is waiting because the connection is still open. We didn't close it. So let's close it. Con.close. And again, this returns an error. So you should be checking it. But I'm lazy, so I will not be checking it. But in general, when there's errors, those things might be wrong. So if you're reading a file and you close it, that may return an error, and probably you don't care. But if you're writing and you close it and that returns an error, probably you didn't flush the buffer, so there might be data that you lost. So in those cases, you need to check them. So sometimes it's important to check them, sometimes not as much. In this case, it's really not that important. All right, so let's run the server again. Cool. It works. Amazing. OK, so now we have a TCP server that just says hello, CERN. So, I mean, not incredibly useful. So let me see. So next, we're going to do an echo server. So it's going to be much better because I'm going to be able to say things, and it will say them back to me. So what we're going to do is we're going to replace this with IO copy. So IO copy is a function from the IO package that reads from a reader, writes into a writer. That's it. So we're going to be copying from the connection into the connection. Both are read and writer, so you can just do con. Cool. That is echo server in Go. Let's try to run it. Hello. Amazing. OK, so so this is working now, right? But can anyone see a potential problem in this code? Sorry? Closing the connection is not a problem, because actually, when I close the connection here, it will be closed from the reader, so the copy will finish.
Like very, very large.
No, that's not a problem. It's actually all buffered. It's all magically done, and IO copy actually works really well. This is the basic of all of the Go standard library, so it's actually very, very efficient. The problem. Yes, exactly. So let's run this. And this is why I have two different terminals. So I'm going to netcat localhost. Hello, amazing. Localhost 4000. Hello, what? Where are you? So this is not working, right? Because our program is actually waiting in this copy. So while it's waiting on this copy to finish, so for this connection, the first connection to close, it's not accepting the second connection. So when we close this one, now the other one receives all the things and returns it back, right? So this is a problem, because normally if you create an echo server, you might want to have more than one user at a time. So we're going to need to do concurrency. So let's see how. So concurrency in Go is not very complicated, and that is awesome. I do not have one because I decided that I will write it from scratch. So Go routines. Mango Go. PKGM. Okay, so let's say that you have a function that says my favorite things, talk and sleep. So there's a message and then some duration, time.duration. So this does time.sleep for that duration, and then prints a message. Okay, so now I'm going to do talk and sleep, hello. So after time.1, the other way around. Okay, so talk and sleep, yeah, true. Okay, so after 2 seconds, there, and after 3 seconds, we're gonna print CERN. Okay, and so if we run this, so go run example, go routine, main.go. This will wait for 3 seconds, print CERN, 2 seconds, print there, 1 second, print hello. So now what I want to do is I want to do all of those 3 things at the same time. So then they will all start counting at the same time, and the message will be reversed. So in order to do that in Go, you do go. That's it. Go, go, go. That creates a new Go routine. That's what we call it. And basically, it starts that new function in a different Go routine, which is kind of like a thread, but way faster. You can run millions of Go routines in this computer without burning it out, which is good. So, OK, so let's try this. So it's faster, but it's not printing anything, right? What is the problem here? Well, the problem here is that the main Go routine is actually important. The main Go routine is, as soon as it finishes, which is the Go routine that started the main function, as soon as that one finishes, the whole program stops, right? So let's fix it by doing something that you should never do. Sleep for 4 seconds. So now the main Go routine is going to wait, right? This is really bad code, but it's just an example, so don't judge me. OK, so now we get hello, there, CERN, we're finished. So that's how Go routines work, right? Cool. So how do we make this a concurrent echo server? Go. That's it. Now every single copy will start in a different Go routine. So we'll be able to handle as many connections as necessary. So we're going to go run main.go. Go here. Go here. Hello. Is this working? Yes. OK, so now we have 2 connections, and actually you could have as many as you want. Probably you could have as many as the OS supports connections open at the same time, because that is the lower limit, not the number of Go routines. There was a talk I went to on Monday about how to serve 1 million WebSockets with a single Go binary. That is something that you can do. It's not easy, but you can do it. OK, so cool. So we have the concurrent echo server. So the next step is we're going to make this into chat roulette. So read, yeah. We're going to get there, yeah. So we're going to be implementing, you could consider this a slide, but it's not. So what we have so far is this thing on the left. We have that main server that is doing all of the accepts, and for every connection, it creates a new Go routine. So every block is a Go routine where we do IO copy into itself. So now what we're going to do is we're going to do the chat roulette web server, where we're going to have, for every connection, we're going to start a different thing. It's going to be a match function. And that match function, we're going to have 2 match functions, and they're going to agree somehow to one of them give the connection away to the other one. We don't know which one. And the one that gets the 2, it's going to start the chat function. And the chat function is going to do 2 things: copy from A to B and copy from B to A. So we're going to basically establish the connections, the copies in between the 2 connections. So now the interesting thing is, how do you do this, right? How do you make sure, how do you join 2 different Go routines into one single thing? You could use mutexes. And think about how you would do that with mutexes. It's not easy. Probably the first try is going to end up with deadlocks, for sure, right? So instead of using mutexes, we're going to use Go concept. It's called channels. So let's see the channels example. So the channels example is pretty cool because here we're going to do is we're going to have this fib function like the one yesterday, but instead of returning a value, what it's going to do is it's going to be sending values through a channel. So you see it receives write-only channel of integers, okay? So we can only write into it. And what we're doing is we're writing A into C. That arrow, that's how it works. That's the send and receive operator, depending whether you put it on the left or on the right of a channel. Here it's on the left, on the right of the channel, so it is a send operation. Then on the other side, we're going to be receiving from that same channel, okay? That is receiving from the channel that returns an integer because it's a channel of integers. And then we just need to create the channel. You didn't see that. Create the channel and also start the new Go routine. We need to create the fib function in a different Go routine because otherwise, if we did like this, what's going to happen is fib's going to start. It's going to try to send that first element through the channel, and then there's no one on the other side to receive, so we're going to block. Channels are by default synchronous. So only when one Go routine is ready to send and one Go routine is ready to receive on the other side, the operation actually happens. So it's not only communication, but also synchronization. So let's try to do this, actually, this code that is wrong. By the way, all of this code will be in a repository that I will open source at the end of the session, so you can check it out. All right, so go run examples, channels, main.go. OK. Fatal error, all Go routines are asleep, deadlock. Because we only have one Go routine that is trying to send something into a channel, and there's no other Go routine to try to receive it. So this is why we need to do go fib. We need to start that function in a different Go routine. So now we have the sender and the receiver. Yeah?
The deadlocks, are they detected at compilation time or only at
No, the deadlock is detected only at runtime. There's some tools to detect things a little bit more advanced, but they're not very powerful. This one is detected, the deadlocks are detected at runtime anyway, all the time. You can also run go run -race main.go, and that will actually also run the program with a race detector that will also find other concurrency problems. It will make your program around 10 times slower, so not production thing. But for testing, it's definitely worth it. OK, so now that we have that, we run this, and we see that we're receiving and sending, and everything is working. The receive and send might switch because we don't know which Go routine is going to get to print first. That's why. But you're seeing that they're always synchronized. Like the send and receive happen at the same time. One thing that you could do is, for instance, say, actually, I don't want this channel to be synchronous. I want to add some buffer to it. So now by adding 10 in here, we're adding a buffer capacity of 10 elements. So when you run this, you're going to see that 10 elements are sent directly because there's the capacity. And then we're going to wait until there's more capacity ready. So that's why we're going to receive and then send one more, receive, send one more. So, and still we're going to get the same values of Fibonacci. OK, any questions about channels? OK, this is how channels work. And this basically, there's many more things, but this is the basic thing we're going to be using today. OK, so let's start. So what I'm going to do is go match of the connection. And I'm going to create a new file. Match.go. Package main, func match of net.conf. So now what we need to do here, and this is the part that I really like about this program. What we need to do is we need to figure out a way, given two Go routines, to choose one that is the winner, that gets both Go routines, both connections, and that's the chat. And the other one is the loser and just stops, right? And we're going to use channels for this. In order to do this, actually, we're going to be using one more construct, which is not explained in the example. So let me add one more, which is select. And select is the one that allows you to do multiple things at a time. So if you have, for instance, time.tick, it's something that returns it's a useful thing from the time package that gives you a channel that every duration it will give you a new value. So let's say that every second we're going to get something. Okay, and we're going to call this tick. And then we're going to also use time dot after. And time dot after, so let's say 4 seconds. So after 4 seconds, it sends one value. Okay, you could implement these things with Go routines yourselves, but this is much more efficient. All of the timers that you might be setting up, they're going to be using, in general, 1 or 2 Go routines, no matter how big your system is. So it's definitely better to do this than generate many Go routines. So we're going to call this boom. All right, so now what I want to do is, in a for loop, we're going to see what we're receiving, whether we're receiving something from tick or boom. So that we're going to do select. And select has cases. So this is kind of like a switch, but every single case is going to be a channel operation, either receiving or sending. So we're going to say that if we receive something from tick, we're going to print tick. And if we receive something from boom, we're going to print boom and return. Okay? So this is how you can do multiple things at a time with Go. So let's try to run it. Go run examples, select main.go. Tick, 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 and boom. Tick, 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 boom. Okay, you never know when this happens. So let me do 0.25 and 1. So the examples would run faster. Oh, except that this needs to be, so let's do divided by 4. Tick, 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 boom. So that is 4 ticks. That is 4 ticks. Oh, come on. That is 4 ticks. Okay, so this is pretty incredible because it's weird. But when 2 things happen exactly at the same time, which is one of the ticks and the last tick and the boom technically happen at the same time, the one that will happen is random. You do not know. And that's actually the whole point of select is pseudo-random numbers generation. So in general, it will choose 1 every time. And this avoids problems when one of the channels is very busy to avoid a starvation on the rest. Okay, so now that we know how select works, what we're going to do is, actually, match. We're going to create a channel of connections. And we're going to call that partners, which is make a channel of net.con. And what we're going to do here is, so we're going to be, first, we're going to let the connection know waiting for a partner, ... And then we're going to do select. And what we're going to do is we're going to try to send our connection into the channel and to receive a connection from the channel. So if there's no one else waiting, that will block. But as soon as someone else arrives, randomly, we will be able to either send our connection or receive the other partner's connection. So that's going to be either we're able to send our connection into partners and bye-bye, or we are able to receive a partner from, and that is a short variable declaration where we're receiving from the channel. So the type of P will also be net.con because it's the type inside of the channel. So what we're going to do here is we're going to do chat of con and P. Okay, and we'll decide what chat does later. So A and B are going to be net.con. And for now, let's just say we're going to print into A, partner found. Say hi. And we're going to say the same thing to B. For now, this is what we're going to be doing. Just we're going to say, hey, we actually found someone, and you're going to be doing these 2 things. So let's try to run this. So actually, now that we have multiple files, and this is something very new. This is something from Go 1.12, which means that it was released yesterday, so you probably will not have it if you install the latest version. But you can do Go run, and it will run everything inside of this directory. This is cool and new. Okay, so when we connect here, it's going to be waiting, saying, OK, I'm waiting. We're in the select statement. We're trying to send our connection. We're trying to receive a connection, but there's no one else on the other side. So we're just blocking. And when we do netcat here, now they're both connected. So if I say hello, nothing happens. Why? Because we have not set the copy, right? Now we need to copy from A to B and from B to A. So let's do that. And this is going to be something very complicated. Copy A to B, copy B to A, and we're done. Now we're copying from A to B and from B to A. So if we go back to the image, we just did this part here, the IO copy. We just generated those two new Go routines. So now we've implemented the whole thing. Now we have a chat that should be working. OK, so let's try it. Let's run it again. Let's connect. Let's connect. Amazing. Cool. You're awful. I hate you. Bye. What? Why? Sad face emoji. There you go. Oh, come on. There you go. Oh, OK. So what is the problem here? The problem is that one left, and the other one doesn't know about this, right? So we need to somehow figure out when one of the connections closes so we can close the other one, OK? So that is actually related to checking for the errors. What error? Well, IO copy returns the number of bytes that we're able to copy, and also an error if something went wrong. And that error might be nil when everything went fine, but still we finished, right? So we're done, but we actually done, nothing bad happened. We're still receiving a value. So we need to check for the return, for the value returned by this function. And you cannot do that when you're calling it with Go. When you're doing Go something, you're basically letting those values go away, right? So we're going to need to define our own copy function. So we're going to do A to B and copy B to A. And our function copy is going to be A, and we're going to define it already as a writer, a reader, and we're going to call, so copy A to B, B to A. We're going to get that error. And now the question is, if we have two different Go routines, actually three of them, we have the Go routine running chat, we have the Go routine copying A to B, and the Go routine copying B to A. How do you communicate across Go routines? And the answer is channels, again. So what we're going to do is we're going to create a channel of errors. So we're going to do the channel of errors is channel of errors. And we're going to pass it here, and we're going to pass it here. And so RC is a channel where you can only write into of errors. OK, so so yeah, so the underscore, so this is actually the number of bytes, right? So if now if I'm going to actually send the error that we received into the channel. And this will not compile. And it will not compile because I'm declaring a variable that I'm not using, and is declared but not used. To avoid this problem, what you need to tell the compiler is, I know, but I just don't care about this value. So in order to do that, you use the underscore one. The underscore is basically depth null of variables. Just like, drop it. We don't care. OK, so now we have this. But so we have the two Go routines sending their error through the channel. We just need to receive it. So we're going to receive it. And if the error is not nil, we're going to do log print ln error. And if not, we're going to exit anyway. So we'll be done. OK. So now with this, we're going to be able to basically actually, and of course, we're going to close the connections, because that's what we were waiting to do. So we're going to close A, and we're going to close B. If you close a connection twice, it's not a problem. So one of these connections will actually be already closed. That's why we finished. But we don't care. We're just going to be closing both. OK. So let's run this. Go run. Localhost. I said bye. OK. So now when we close one, the other one is notified, and it also drops the connection. So now we know that there's no point of trying to insult the other partner because they will not listen to it. Okay, so there's a mistake in this code. And the mistake in here, for those that write Go, this is pretty subtle. But there's a mistake in this that will not show in your tests. But if you deploy this in production, after a while, you'll see that there's a memory leak. And the memory leak is related to, let's print done with copy. If we do done with copy here, you would expect this function to print it twice per chat, because you close A and you close B, so those two connections should finish. So let's try to do that and see what happens. Done with copy once. So there's another Go routine that is not finishing, and it's blocked there forever. And Go routines use memory, which means that there's a memory leak. Okay? So what is the problem here? The problem is that we have this channel of errors, and we are sending 2 errors, right? But we're receiving only one. So we receive the first one, we leave the channel there. The other Go routines tries to send a new value into that channel, a new error into that channel, and no one's receiving it, so it blocks there forever. Now, since the Go routine is blocked there forever, it's still technically alive, so it's keeping a reference to the channel. And the channel is keeping a reference to the Go routine. So they're both keeping themselves alive, and the runtime will not free them. So that's a problem. So how we can fix it? Well, what we can say is that either we receive twice, so we could fix it by doing this. This would fix it. We're just receiving once more, because we know there's going to be 2. Or we can say we're allowed to have 1 extra value. That will also make it. Because now what we're doing is we're saying the second Go routine will put the value in there, and it's done because it's not a blocking operation anymore. So this Go routine will finish, this Go routine will still finish, and the channel will not have anyone keeping a reference to it, and it will be garbage collected. So let's do that. Let's see if it works. Go run. Bye. Okay. Done with copy, done with copy. Now we have both Go routines finishing. And this is the kind of thing that you will not notice while you're writing the code. And then you'll put it in production, and you will start seeing like that memory, the heap going up and up and up, and eventually crashing. So it's important to take this into account. Okay, so let me see. Channels. Cool. So we're done. Yeah, questions? You don't need to close it. Closing it is not necessary. Closing it is just a way to let all the readers know that there's no more stuff coming. But in this case, who is the one closing it, A or B? Right? Like you have 2 different Go routines, but they do not know who's the last one. So if here you did something like close the channel, this will actually panic. Let me show you that. So if we do this, and we close it, this will panic. Because the first Go routine closed the channel, and the second one tries to send something into a closed channel, and that is a mistake. So that will panic. So yeah, you do not need to close all of the channels. It's something that sometimes you can do, and it's useful, for instance, in the Fibonacci example. If you wanted to say, I'm sending 10 values, and then I'm closing it. You could do that. You could say, sending 10 values, and then I'm closing it, so the receiver doesn't need to know how many values they're going to be receiving. They can just receive, receive, receive until it's closed, and then they're done. So different ways of doing it. Yeah?
Why does it stop in the, like, after doing the Go copy and it's waiting there?
Because until one of the functions here doesn't send that error, there's nothing to be received. So until there's something to be received, receiving blocks. Yeah. Okay. Any other questions about this code so far? Yeah.
Why is GoVet complaining about RC?
It's not GoVet. It's a different thing because it's saying that this misspelled. Yeah. Yeah. It's RC is apparently not right English. But yeah, it's not GoVet. Cool. Okay, so next what we're going to do is, okay, so this is not 1995. So people do not use TCP to talk to each other. They use web. So we're going to try to build a web server that is going to do the same thing. So how do you do web stuff in Go? So let's start with the easy one. This is a web server in Go. It's pretty straightforward. This web server, what it does is it says, when you receive a request with a path that starts with slash, and all paths starts with slash, which means that all requests will be handled with this handler. And this handler needs to be of type a function that receives a response writer and a pointer to a request. So that's exactly what we're defining here, this handler. And a response writer is a thing that does many things, but one of the things it does is a writer, right? So you can actually use it as a writer. Again, like in Go, reader, writer, those interfaces, you're going to see them everywhere. So you can do fprintln hello web. Okay, so Go run examples web main.go localhost 4040 hello web. Cool, we have a web server. And these already, I mean, this is a very bad example of showing you that it is actually scalable, but every single request will be handled by a different Go routine. So the concurrency in this is already built in. Yeah.
Did it also send the response pattern?
Yeah, actually, so if you do curl-v localhost 8080, you will see that it sends content length, content type, and the headers and stuff. This is why if you compare a Node.js simple web server with a Go web server, the Go web server is slower because we do the things you need to do. Just saying that it's very easy to prove whatever you want with a macro benchmark. Okay, so with this, now we're going to do is this is something that I already prepared before because I don't have the patience to write all of this. No, this. Okay, so this is an HTML website that what it's going to be doing is actually going to be using WebSockets because what we're going to be doing is connecting through a WebSocket to our server and to keep the chat going, okay? This is JavaScript, and I'm not going to be showing too much detail. The important thing right now is that we need to be able to serve that website. So this is an HTML thing, but it's actually not an HTML, a real HTML thing. This is actually a Go template. And it's a Go template just because there's this thing here. That little thing with the two brackets, two braces, that is what we call an action for templates. And what it's going to be doing is it's going to be replacing whatever value you pass here. So what we're going to do is we're going to pass our own address, the web server address, into there, right? So then the WebSocket will be able to establish a connection. So the important thing right now is we need to be able to read all of this and somehow send it through the web server. So let's do this. I'm going to comment this out. We might use it later. So func main, we're going to do HTTP handle func of everything is going to be served with root handler. And then we're going to do HTTP listen and serve into localhost 8080 and nil because we're going to be using default router. Okay, root handler is not defined. This is something that you do so often that actually there's a short thing to write it, which is nice. Root request. And now we're going to be doing, we need to now get the content from that file and parse it as a HTML template. So we're going to do template.parse files. And it is in template home.html. That will, yeah. I don't know why Go import is very confused. I think it's because I'm using Go modules in this example. But that is totally wrong. I'm actually using HTML template package, which is part of the standard library. This will return a template and an error. I'm going to do template.must. And template.must gets a template and an error. And if the error is not nil, we'll panic. And the good thing is that that allows me to use it here. Root template is this. So now I'm declaring at the beginning of the package, I'm declaring that variable that will read that file, parse it, and if anything goes wrong before the server starts, everything will just crash. And then here I can use root template.execute. And execute receives a writer, because we're going to be writing that template, the result of executing the template into a writer, and then the value that you're passing into it. So that's going to be our response writer. And also localhost 8080. So let's define it as a constant outside. Constant HTTP listen, HTTP address equals this. So we're going to use HTTP address and HTTP address. This execute will return an error. So we want to check that out, just in case our template, when we execute it, is somehow wrong, it fails. We might want to check that out. So we can do, error. And if the error is not nil, probably you want to log it. Printf could not execute template and the error. Okay, so now with this, we should have a web server that is returning the content of that file. Let's run it. Go run. Let's, actually, let's do that. Dope. Go run. Oh, because I'm running the wrong file. Yes. Go run what I said I wanted to run. Okay, so we are getting all of the HTML that we defined, but also here we have localhost 8080. So we actually replaced that action thing with the value that we wanted. So, and this looks like this. I am not a front-end engineer. But right now what we have is basically a web server that a website that tries to connect to a WebSocket, and the WebSocket is not there, so it says connection closed, I cannot chat with anyone, okay? So let's fix that. Let's create WebSockets. So how do we do WebSockets? Not the way I'm going to show you. The way I'm going to show you is actually a library that I really like, but it's not really complete, so I do not recommend using it for production. But for this example, it actually works really well. So let's go to the example, and we have WebSockets here. Okay, so this looks very similar to what we did before. The only difference is that that handler function is going to be of a different type, because we're going to be using this WebSocket package. And the WebSocket package, what it does, it defines a type handler that is a function that receives a connection. And this seems kind of weird, but the idea is that this handler is actually a type, not a function. So what we're doing here is, wait, did it go away? WebSockets. Yeah, so what we're doing here is not a function call. There is actually a type conversion. We're converting this function into the type WebSocket.handler. And why are we doing this? Well, because the handler here has a method serve HTTP. So we're defining a function, we're defining a method on top of a function, which is the kind of thing I told you was kind of weird, but actually we do it all the time. And now that allows us to make this function satisfy the interface required by handle, which is the interface handler. Okay, so if you go to the handler interface, this interface here, actually let's do it, go doc net HTTP handler. It is an interface that has just one method, serve HTTP, which is the method we define on the function. So now our function defines an interface by adding a method. It's kind of weird, but you will see this in Go all of the time. So I'm going to say it's elegant, but oh no. Good GIF. Let me open it again. VS. Okay, so are we? No. So 1 second, code this. Okay, so let's go back to the WebSocket example. And then, so that connection, now basically this is the handler that we're defining. And rather than receiving the HTTP response writer and the request, we just received a WebSocket connection that happens to have an open So a read and a write method. So we can also use it as reader and writer. So we're going to use fscanLn to scan something. So we're going to scan a message from the connection. We're going to wait for something to arrive, and then we're going to send back hello WebSocket. So we're using it basically as a net connection, even though it's different, but it satisfies reader and writer, so we can use it the same way. Okay. So let's run this. Examples, WebSocket, main.go. And then we're going to get this JavaScript code. And let's do it here. Console and go away. OK, so this will establish a new WebSocket. Let me move that out of the way for now. And this one here. OK. This will set a handler for whenever we receive a message to print it into the console. And next, we're going to actually send the message. So when we send the message, here we received hello, and then so we printed that hello from here, and then we sent hello WebSocket through the WebSocket that was received here, and this printed hello WebSocket. So now we're able to communicate through a WebSocket from JavaScript to Go. Okay, so let's do that now inside of our program. So in our main program, let's see how we can do that. Okay, so what we're going to do is we're going to have to handle two things at a time. How do we do that? Two different addresses. That's it. So we're going to say HTTP handle /socket. So any request going into /socket, they're going to be handled not by sending HTTP back, but by opening a WebSocket. And that's going to be WebSocket.handler socket handler, which we have not defined yet. Okay, so socket handler, it's going to be func socket handler of WebSocket.connection, which is a pointer. And now in here, we're going to do, so what can we do with this? Well, this is a connection, but it's not a net.con. So we cannot call match.con, unfortunately. So here's the part where interfaces come handy. Because what are the things that we are actually doing with the connection? We do not need a net connection. What we're doing is we're writing into it, so we need a writer. We're reading from it, so we need a reader. Or we're closing it, so we need a closer. So we can say IO read, write, closer. That's an interface that has three things: read, write, close. So anything that satisfies those, we're good. So now this works. Now we can pass a WebSocket connection as a read, write, closer, because it is also a read, write, closer. So let's try that and see why it doesn't work. So I refresh this, and when I refresh this, now we're going to have that match. And connection closed. So good, right? Like we were waiting, the match actually worked, but as soon as something happened, it just closed. What happened here? Well, the problem is that this match here, as soon as this function is done, the socket handler, as soon as the socket handler function is done, the WebSocket package will close it. So we need to somehow make it wait. And this is where it becomes interesting. So this a part that is also very cool. We're going to create a socket.go file, and it's going to be also package main. And not func main, though. We're going to have a type socket. And this type socket is going to have a read, write, closer. But we're going to have, so close is actually something we can wait on. So we're going to have a read writer. And then we also have a done channel, which is a channel of booleans. Why booleans? Because it's nicer than to use an empty struct. We don't really care about the value. We're just going to use it as a synchronization barrier. Why are you complaining? Oh, struct. All right. So we have that type socket. And now what we need to do is we need to make it so close does something. Right now, if we create a new socket, we say, I'm going to create a socket with the connection and a make channel of booleans. And that is our socket. If we pass that there, this will not compile because it will say, hey, you're going to use this type socket as a net.conf? What? Okay. So that is actually read, write, closer, which means that this is a IO read, write, closer, and the rest we're fine. Okay. So still, this should not work because socket does not implement IO read, write, closer because you're missing the close method. So we need to decide what to do with close. So close that returns an error. It's going to send true into done. And now the interesting thing is that we're going to be using this as a sign that the channel is ready to go. So here, we're going to read from s.done. So now this function will actually block, because we're reading from a channel, until someone calls close, and then when you call close, true will be sent to done, s.done, sorry. Therefore, I'm blocking this, finishing the handler, and actually closing the WebSocket. So we're basically making the whole thing wait a little bit by adding that channel in there. What if you wanted to do something where you have multiple people waiting for that? How many values do you need to send? That will not work, right? So there's a better way of doing it, which is closing the channel. If you close a channel, reading from it, it will just give you the 0 value. So that means that all people waiting from that channel will be unblocked completely. So when you want to broadcast a signal, that's how you can do it, with closing a channel. And return nil. What? Return nil. Okay, so now this looks like my work. So let's run it. Go run dot, sorry. Refresh. Hello. Wow. Nice. And if we close this one is also closed. So all of the code that we wrote before is still working for this, for HTTP. And now with just 7 minutes to finish, I wanted to do one more thing, but there's no way I have time, which is actually adding a bot that after 5 seconds, it will tell you, hey, I'm a bot, let's chat together. And it uses a Markov chain to generate code. So yeah, it's fun. In the code that I will open source, that will be part of it. So if you see a Markov.go, that's what it's doing. But instead, what I want to do is, okay, so what if now I want to say, okay, so yes, web pages are great, but we also have like really old school people that want to use TCP, right? So now I want to use TCP and WebSockets on the same server. And I want to be able to have people talking from TCP into people using the web client. Is this possible? So you remove the comment. You say handle TCP, and then go handle TCP, and you're done. Because now you have 2 different Go routines that are listening on different ports. So this is the whole idea of composition, right? Like we've been doing composition of types thanks to interfaces, and composition of processes thanks to Go routines. So you run this, you refresh this, you go back here, netcat, hello web. Wow, that's cool. You close, and this one receives connection closed. So now all of the things are able to work together because we're able to compose all of the different servers in a very easy way. And this is actually something that you will see at Google all the time. Internally, all different projects use pprof. Pprof is the thing that allows you to trace what's going on in production with a Go program, and actually with many different program languages. That exposes it as a web server. All jobs, no matter what they do, no matter if it's MapReduce or a web server or whatever, they all expose a web server. And how do they do it? They do just go pprof serve. That's it. You don't need to do anything else. The rest will be handled automatically through Go routines. So that's it for the demo. And so that worked well. So For the original slides for this talk, they're all online, and actually, the slides here, I will share them later on, like tomorrow at the end. You will have all the slides that I've used. And in the slides there's also recording for a talk from 2012. And you'll hear Andrew, my mentor, giving this talk in Australian. Also, there's a couple of talks that I really like. Concurrency Is Not Parallelism is a talk by Rob Pike, talking about the difference between what is concurrency and what is parallelism. Why are they different, and what does it mean for Go? It's a really good talk if you're interested about like the philosophy behind Go concurrency patterns. Then you have Go concurrency patterns that explains all of the different cool stuff that you can do, fan in, fan out, how to do many workers, communicating, all that stuff. It's a very useful talk. And once you go through that one, there's another one by Samir Ashmani from the Go team called Advanced Concurrency Patterns. In that one, you learn how to implement state machines with Go routines and select statements. And that is actually, it's a way of basically designing your code in a very, very elegant way. So I definitely recommend checking it out. It's a little bit more advanced, so definitely go first through Go concurrency patterns before you go into advanced Go concurrency patterns, otherwise it's gonna be pretty confusing. And then Young Grant Cummins, which is the CTO of Cloudflare. He gave a really good talk at .go, which is I came for the easy concurrency, and a state for the easy composition. It's like a 20-minute talk on how, like a very useful Go pattern. So that one is also a very good introduction if you're interested in that. And thank you. So time for questions. Also, you can clap. Thank you. I saw someone go like. Any questions about Go routines and channels and composition of interfaces and processes? Everybody's hungry. Yep. Oh yeah, we have the mic. It's not on right now.
Yeah.
Okay, cool. I can repeat the question too, just say it out loud.
Repeat the question, I don't know.
So there's no concept of waiting for the subroutines to finish their execution. All the communication happens through channels?
Yeah, all the communication happens through channels. There's a very weird way of knowing the ID of a Go routine, but it's something that it's only used for debugging, really. And in general, that's not how you build concurrency in Go. Yeah, there's no like in Linux, in Linux you would do something like wait until the thread dies or something like that. Not such a thing in Go now.
There's a package with a wait group.
There's a package with a wait group, yes, that actually uses the wait group. So actually, that's a good point. There's a Golang.org sync. This has some other things that you can do for concurrency. Like everything I showed today was channels. But that doesn't mean that everything in Go needs to be done with channels. If, for instance, maps are not safe to use concurrently. If you have two different Go routines, writing and reading in the same map, that will go wrong, okay? So you need to protect it somehow. Using channels is a way of doing it, but it'd be pretty awkward. It's much easier to use a mutex. So you also have sync.mutex, sync.rwmutex. So depending on whether it's something that reading and writing is around the same, or writing is rare, but reading is very common. So you have both. You have conditions. You have the sync.map. Sync.map is when you want to do a concurrent map, but it is a very specific thing that you should, in general, not try to use. It's basically used by the rest of the standard library for very low-level things. If you want to use it, it's an interesting thing, but I would not recommend trying it directly. Try normally a map with a mutex, much easier. And sync.pool is also something that is used for pooling objects. The cool thing about this, it has the power of understanding the runtime. So the garbage collector cooperates with this. So you can, for instance, you are reading a lot of different things and you don't want to create too much garbage, you can use a pool of objects to reduce the garbage that you're creating. Of course, you need that to work over many Go routines, but that's why in sync. Yeah, and the wait group is the one that allows you to basically say, I'm going to wait until like 100 Go routines are done. Every Go routine, once they're done, there will be wait group.done, and then there's a wait group.wait that will wait for everything to be done. That's actually part of the, in this talk, the last one, I came for the easy concurrency, stay for the easy composition. That's what they talk about how to use wait groups with Go routines. Any other questions? Cool. So tomorrow, we're going to be talking a little bit about tooling, about how to figure out how to make your program faster. And then my goal is to leave extra time for questions. So if you have questions about anything related to Go, probably, just send it there to francescacampoy.cat, and I'll take the time to go over all of them and answer them tomorrow. So if you have questions about either something that I have explained today or yesterday, or any other thing that you'd be curious about the language, just send it there. Okay? Cool. Thank you. See you tomorrow.